Micro black hole. Let's start small, really small. When you think of a black hole, you think of a dead star swallowing planets. But the math of quantum mechanics allows for something far stranger. A black hole's the size of a single proton. If a micro black hole popped into existence right next to you, you wouldn't be sucked in. You wouldn't even feel it. In fact, it would be gone before your brain could register it was there. Here is why. Black holes leak. A process called Hawking radiation means that over time, black holes bleed their mass away into space. For a giant black hole, this takes a Google years. For a micro black hole, it takes a fraction of a second. It evaporates in a microscopic flash of heat and light the instant it is born. A black hole that dies before it even realizes it exists. Stellar black hole. This is the classic, the textbook definition. A stellar black hole is what happens when a massive star runs out of fuel. The star can no longer support its own weight, and gravity wins. The core collapses inward at a fraction of the speed of light, crushing the mass of multiple suns into a single, infinitely dense point. To understand the density, imagine taking the entire Earth, every ocean, every mountain, every building, and crushing it down until it fits inside a marble. That is a black hole. Around that point is the event horizon, the point of no return. Cross this invisible line, and you have left the observable universe. To escape, you would need to travel faster than the speed of light. And since nothing can travel faster than the speed of light, you are trapped forever. If you fell feet first towards a stellar black hole, the gravity at your feet would be millions of times stronger than the gravity at your head. You would be stretched out like a piece of cosmic taffy. Astrophysicists literally call this spaghettification. You are stretched into a stream of atoms and quietly pulled into the dark. Intermediate black hole. We know how small black holes form. We know how the massive ones form, but for decades, scientists had a problem. The math said there should be a middle child in the cosmic family. Black holes weighing roughly 1,000 to 100,000 times the mass of our sun, but we couldn't find them. The universe was hiding them. Intermediate black holes are the missing link of astrophysics. They don't usually have giant glowing rings of gas around them to give away their location. They lurk in the dark, silent and invisible. The only time we can actually spot an intermediate black hole is when it gets hungry. When a wandering star drifts too close, the black hole wakes up. It doesn't swallow the star whole, it shreds it. This is called a tidal disruption event. The star is violently ripped apart, screaming out a flare of X-rays that can be seen across the universe. Once the meal is finished, the black hole goes quiet again, disappearing back into the void. Supermassive black hole. This is where things start to get out of hand. At the center of almost every large galaxy in the universe, including our own Milky Way, sits a monster. Sagittarius A star is the supermassive black hole anchoring our galaxy together. It contains the mass of 4 million suns, but even that is on the smaller side. The black hole at the center of galaxy M87 has the mass of 6.5 billion suns. Despite their terrifying reputation, supermassive black holes are not cosmic vacuum cleaners. They don't just suck everything up. If you replaced our sun with a black hole of the exact same mass, Earth wouldn't get sucked in. It would just keep orbiting in total darkness. The danger is the accretion disk. The swirling ring of gas and dust trapped in a supermassive black hole's orbit is moving so fast, the friction heats it to millions of degrees. It becomes plasma. The disk surrounding a feeding supermassive black hole shines so brilliantly it can outshine the entire galaxy of billions of stars that surrounds it. It is the brightest darkness in the universe. Ultramassive black hole. Forget out of hand. This is where human comprehension breaks. Deep in the cosmos, there are black holes that have grown so impossibly large. The title supermassive is no longer accurate. Meet TON 618. It is an ultramassive black hole containing the mass of 66 billion suns. To put that scale into perspective, a stellar black hole is the size of a city. A supermassive black hole is the size of a star system. TON 618 is so gargantuan that you could fit our entire solar system inside of it. Then you could stack 40 more solar systems end to end, and they would all still fit inside the event horizon. It is a shadow the size of a solar neighborhood. An object so heavy, it dictates the movement of thousands of galaxies around it. And the most terrifying part, we don't actually know how it got this big. There hasn't been enough time since the universe began for a black hole to eat enough matter to reach this size. It shouldn't exist, but it does. Naked singularity. A black hole is made of two parts: the singularity, the infinitely dense dot of crushed matter at the center, and the event horizon, the black sphere that hides the singularity from the outside world. But what if you strip the event horizon away? In theoretical physics, this is called a naked singularity, and it is the one thing in the universe that truly terrifies scientists. Inside a singularity, gravity is infinite. Space and time cease to exist. The fundamental laws of physics completely break down. The only reason we don't have to worry about this is because the event horizon acts as a cosmic quarantine zone, keeping the broken physics locked away. But if a black hole spins fast enough, the math suggests the event horizon could flatten out and eventually tear open. The singularity would be exposed to the naked eye. Looking at a naked singularity would be like looking at the universe's source code and realizing it's glitching. Cause and effect would shatter. You could see the future before the past. Reality itself would unravel. Primordial black hole. Every black hole we have talked about so far was born from the death of a star. Except these. Primordial black holes are ancient. They did not come from dead stars. They came from the Big Bang itself. In the very first fractions of a second after the universe was born, space was not empty. It was a boiling, violent soup of pure energy. In some places, this energy was packed so tightly together that it instantly collapsed into tiny black holes. These objects are incredibly small. Some are the size of an atom but weigh as much as an asteroid. Others are the size of a golf ball but weigh as much as the Earth. Because they are so small and dark, we can't see them, but physicists believe they are everywhere, trillions of them, drifting silently through the dark space between stars. It is entirely possible that a primordial black hole the size of an atom passes harmlessly through our solar system, or even through the Earth itself on a regular basis. You would never know. White hole. For every equation in physics, there is usually an opposite. If you take the mathematical equation for a black hole and you run time backward, you get this: a white hole. It is the exact opposite of a black hole in every single way. While an event horizon prevents anything from escaping, the horizon of a white hole prevents anything from entering. You could throw all the mass in the galaxy at a white hole and it would bounce off. A black hole consumes matter. A white hole violently, infinitely ejects matter. It is a cosmic fountain of creation, spitting out light, gas, and energy into the void. Do they exist? We have never seen one. But some theoretical physicists believe that black holes and white holes are connected. Matter falls into a black hole, travels through a wormhole, and is blasted out the other side as a white hole in a completely different universe. In fact, there is a growing theory that 13.8 billion years ago, a massive white hole suddenly erupted, spewing out all the matter, energy, and time that currently exists. We call that eruption the Big Bang, meaning the birth of our universe was just the death of a black hole somewhere else. The universe is a violent, dark place, and it is much heavier than you think. If you like this video, consider subscribing. It helps me out a lot.